The impact of artificial intelligence on our everyday lives will be so profound that our modern institutions will change completely. Employment, government, romance, social norms, all of these things will be upended. To see the signs of this coming, you no longer have to read science fiction. Every week there are blog posts, news stories, and videos chronicling our strange, exciting time. Rob May is an investor in artificial intelligence companies and is the CEO of the AI company Talla. Every week he puts out the Technically Sentient newsletter, which is a compilation of the best pieces of information about AI over the past week. Each newsletter also contains a short essay by Rob in which he gives a big picture perspective on what he sees in the AI space and how that's developing from his point of view. This was an illuminating conversation with Rob about the implications of artificial intelligence and the topics that he writes about in Technically Sentient. I recommend checking out the Technically Sentient newsletter. It's a great resource. And I first saw Rob speak at the Launch Scale Festival, which is put on by Jason Calacanis. It's a free event for people who have started companies, and I am grateful for being able to have attended that event and see Rob's talk. And after that, I subscribed to his newsletter, and now he's on the show. So I hope you like this episode. Dice helps you easily manage your tech career by offering a wide range of job opportunities and tools to help you advance your career. Visit Dice and support Software Engineering Daily at dice.com/sedaily and check out the new Dice Careers mobile app. This user-friendly app gives you access to new opportunities in new ways. Not only can you browse thousands of tech jobs, but you can now discover what your skills are worth with the Dice Careers Market Value Calculator. If you're wondering what's next, Dice's brand new career pathing tool helps you understand which roles you can transition to based on your job title, location, and skill set. Dice even identifies gaps in your experience and suggests the skills that you'll need to make a switch. Don't just look for a job. Manage your tech career with Dice. Visit the App Store and download the Dice Careers app on Android or iOS. To learn more and support Software Engineering Daily, go to dice.com/sedaily. Thanks to Dice for being a new sponsor of Software Engineering Daily. We really appreciate it. Rob May is the CEO of Talla and the author of the newsletter Technically Sentient. Rob, welcome to Software Engineering Daily.
Hey, Jeff. Thanks for having me.
I want to start with a discussion of general artificial intelligence. How do you define that term, general artificial intelligence?
People define that sort of two different ways. I think the common way, and probably the term that I would also use, is it always seems to be whatever it is that computers can't do yet. And, that seems to be the case. I think there's a lot of times in the past people have said, when a computer can play chess, when a computer can win at poker, when a computer can win at Go, we'll have achieved general AI. I think we found the opposite. I think what we found is that AI is in a state where we're really good at solving very specific problems with it, and we're not good at building generalized problems. And so I would say a generalized AI is one that can probably solve a broad range of problems the way that a human can. I don't know if the Turing test is necessarily the best test for it, but probably something along those lines. But I think it's a difficult thing for us to engineer at this point in history, because I think we've become very used to, if you think about the software world, what have we always been told? Solve one problem, solve it well, right? Like all of our engineering practices and product practices and everything else are around doing one thing that's very specific. And so we're not very good at or used to building generalized products.
Humans like to think of ourselves as generally intelligent, but there are things that we're not very good at. And in some ways, humans are that specific, narrow sort of intelligence because, for example, a human will never be able to sort and rank like a billion web pages, but a computer is quite good at that. And yet, this is a complex, multivariate task. We might describe it as narrow AI, but there are many things that go into the process of search ranking and serving search results that could arguably be categorized as general artificial intelligence. So, I mean, when I think about this, it seems like even the difference between the notion of general AI, beyond the notion of general AI as something that is whatever is out of reach of our current AI systems, like if you just talk about general AI if you look at general AI as whatever a human can do, because I think that is an alternate definition, the difference between general AI and narrow AI seems to me to be a false dichotomy, because even humans, in a certain light, only have a narrow sense of intelligence. I mean, does that seem plausible to you?
Yeah, no, I think that is true in a lot of ways, right? I mean, another way to answer it might be to say that when we build something that can generalize from specific use cases, right? Use inductive logic and experience the world and form generalizations from that, it will maybe then will have hit generalized AI. I think a lot of what you might be getting at is that the human way of thinking is a process, and it's a kind of process that we haven't been able to put into code yet, despite the fact that we can put some pretty smart things into software and hardware.
Now, some of the approaches I've heard for how we might get to this general AI, or whatever is the AI dream, like name your AI dream, the approach to getting there. Some people say it might be we compose together a bunch of narrow AIs, and these narrow AIs can be composed into something that is general enough. The other approach that I've heard that is somewhat compelling is you write a deep learning system that optimizes for learning how to write a deep learning system. So you get recursive effects. When you look at this from an engineering point of view, do you have any perspective for how we are likely to get to this general AI, this like the singularity level AI?
I don't. I think there's still a bunch of problems that have to be solved. One is, how do you learn from smaller data sets? Some of that's being explored via transfer learning and one-shot learning and stuff like that. Newer techniques like probabilistic programming. I think there's still a question that goes on at the sort of, neurobiology or level, or, neuroscience level, about what base level capacities are pre-programmed into humans and what things do we learn. I mean, there's still a big debate about whether language is innate or not, right? Do we have an innate grammar, or is it very flexible? And there's a lot of evidence on both sides. I wrote a post almost 2 years ago now about this idea that we still don't really understand the nature of intelligence very well. And it reminds me of taking a physics class and reading about the arguments between whether or not light is a wave or a particle. And if you follow that debate, what happened was they basically settled in and said it's both. It has properties of a wave and properties of a particle. And I think it's going to take some kind of maybe, weird thinking around intelligence to come to a similar conclusion about, whether it's innate, whether it's not, how flexible is it. And to take that back to your broader question about where it comes from, I don't have any evidence for this, but my sort of gut feeling and about all this is I think you're going to see changes in hardware, right? I think when you look at spiking neuron chips like what IBM's doing with True North and some of these other like neuromorphic chips that are out there, I think when you look at content addressable memories and some of the changes that are happening, I think we have to really make these breakthroughs. I think we're going to have to break the common computing mindset that we have of this separate memory and processing architecture. So much of our thinking is driven by the sort of legacy, x86 chip architecture that was so popular when most of us who are in the, hardware and software world sort of, grew up and came of age. And so I think some creative hardware breakthroughs and then starting to tool those up so that people can program on those and think in new ways will matter. And the reason I say that is because when I went to school in the mid to late 90s, when I was in college, I was an FPGA programmer, and writing VHDL or Verilog to describe hardware was actually very different than writing code at the time, because people didn't think of code in 1997 as state machines and being event driven and all that. It was very sequential, and people thought about subroutines and stuff like that. And so I realized early on, because I did both software and hardware, that the way you thought about designing hardware was very different. And there were chances to take some of the ideas from one domain to the other. I mean, there's no reason you couldn't build a web page into an FPGA if you wanted to, right? And eventually many of the hardware design ideas sort of made their way over into software if they were useful. And so I think you're going to see, I think it's going to be driven by changes in hardware that are going to open up new ways of thinking about designing programs and, doing approximate inference and stuff like that. And I think those things, those technologies as they evolve is what will lay the groundwork for what will eventually become generalized AI.
I suspect you're right. And it's funny how we often talk about at the software level, how when something, I guess this is generally at the product level, when we get a new paradigm, like the smartphone, for example, the first smartphone apps, the first smartphone web experiences were form-fitting the desktop web experience into the mobile phone experience, and it didn't quite work right, and then it took us a while to get the mobile experience right for these apps and for these mobile web pages. Similarly, the deep learning, what we're using for machine learning for chips right now are GPUs. And basically it's like, well, these GPUs seem to work well for this type of machine learning problem. But now I think, as you articulated, if you totally look at the problem from first principles, you may come to very different conclusions about, okay, is a GPU really what we want to be using for machine learning? And it turns out the answer is probably no.
Right. So it's interesting because what GPUs really do really well is they actually map to neural networks really well, right? Because the GPU is basically calculating, hey, for every pixel on your screen at the next clock cycle update, what should it be? It's a very simple calculation, but it's a calculation that's performed 10 million times in parallel or whatever, compared to a CPU that'll do 10 million calculations much faster sequentially, but can handle more complex calculations. So that maps very well to how a neural network works. But there are other interesting technologies, some of the probabilistic programming languages, some of the ideas like hierarchical temporal memories that are coming out of places like Numenta, and the spiking neuron chips that I think are going to change the way that we think about some of this stuff. And I think, I think that stuff's going to be really interesting.
You are building a data-intensive application. Maybe it involves data visualization, a recommendation engine, or multiple data sources. These applications often require data warehousing, glue code, lots of iteration, and lots of frustration. The Exaptive Studio is a rapid application development studio optimized for data projects. It minimizes the code required to build data-rich web applications and maximizes your time spent on your expertise. Go to exaptive.com/sedaily to get a free account today. That's exaptive.com/sedaily. The Exaptive Studio provides a visual environment for using back-end, algorithmic, and front-end components. Use the open source technologies you already use, but without having to modify the code, unless you want to, of course. Access a k-means clustering algorithm without knowing R, or use complex visualizations, even if you don't know D3. Spend your energy on the part that you know well, and less time on the other stuff. Build faster and create better. Go to exaptive.com/sedaily for a free account. Thanks to Exaptive for being a new sponsor of Software Engineering Daily. It's a pleasure to have you on board as a new sponsor. Yeah, and we'll get back to the hardware discussion a little bit later. I want to ask you about Intel, but before that, let's talk some about Technically Sentient, which is the newsletter you're an author of. I love this newsletter. It's got a ton of links and aggregated content every week. I encourage people to subscribe. It's a once-a-week sort of thing. For you, this must be a great excuse to consume vast quantities of information about AI, and we're in this golden age of content about AI. There's so much content about AI that is interesting, ranging from the technical to the philosophical. It's really just such a cool field to look at. And you're ingesting all of this information, so you must be asymptoting towards some very unique viewpoints, because as anyone who goes into a scientific field knows, the deeper you study something, the more unique and well-defined your vision of that field becomes. Give me some perspective of the unique beliefs that you have around AI.
Yeah, wow, that's a great question. So let me put that in the context of some things that I've written in the newsletter over the years, right? So the newsletter is about a year and a half old. And I think people that know me well would tell you that I sort of don't have a normal life. I don't pay attention to the things that most people pay attention to, but part of my skill set is consuming large amounts of information about all kinds of things. And it's easy to do. I have a unique sort of base to do this from because I was a hardware engineer. I did a report on AI in graduate school. I did a partial master's degree in computer science focused on AI. So I've been studying a lot of this stuff for a long time. And I think some of the things I see that are maybe not that obvious to everybody else. In 2015, I wrote a lot about the AI industry and how this platform approach that was very popular was wrong. So what happened was, with the first real wave of AI funding that started in 2014, venture capitalists, didn't really understand a lot about it. And so the main signal that they looked for in terms of what to invest in was, okay, do you have 3 or 4 smart PhDs who have worked on AI or deep learning or something like that? If so, great, let's just fund you guys and hope for the best. It turns out that a lot of times those people, they don't know how to build companies, they don't know how to go into markets and figure out product needs. And some of them do, just not very many in general. And so what would happen is they would say, well, we don't really have a product idea, let's launch a platform so that other people can build their AI products on it without worrying about the AI part. But the problem is, if you don't understand the AI part, really, then you don't understand how it might change what you might do at the product level. So you had all these platforms that came out, and they were very broad, and the vast majority of them struggled. Some of them got acqui-hired, and some of them pivoted into really good use cases. So like Clarify in particular, I think did a really good job of moving into a market and finding customers and raising another round. And they did that by harping on some end user use cases in their content marketing. So I think when you start with new technologies like this, the early companies actually need to be full stack companies. If you look at what Salesforce did as an early cloud company, it wasn't like they launched, something that was an S3-like thing first, and then Salesforce came after it. No, they had to pull off the entire cloud stack, right? From the, infrastructure layer, from the bare metal layer, all the way up to, the application stack, the application layer. And I think this is what's going to happen with AI. I think the early AI companies, there's going to be some opportunities to build some really big companies, but I think they're going to have to do a lot of stuff themselves. They're not going to be companies that are built on, some of these AI platforms or, NLP platforms. They're going to do most of it themselves, I think. And then as people understand the use cases, I think then the next wave of AI will be to start to platform pieces like that out and make it more available and easier for other people to use. And I don't think that was obvious to everybody at the time, but I think it started to play out that way, right? That the platforms weren't the place to start. I think the second thing that's maybe interesting that most people are missing right now is that, there's this just love of deep learning, which is great when you have a whole lot of data. Most of us don't have enough data to do anything. And I think people aren't paying enough attention to, small data AI. How do you learn from smaller data sets? Because there are many, many more small data sets in the world than there are large data sets. So that's something I see a few people working on. And my guess is if we did this interview a year from now, you're going to say, wow, it's really interesting. Like deep learning seems to be slowing down, and now some new technology or method is really picking up the slack.
Yeah, for sure. I mean, so I agree with that. I also think that what you say there is, it's disheartening in the sense that, yes, maybe we don't have this large enough data sets to pull off deep learning. But what is encouraging about that is we know how to make data. We know how to produce large volumes of data for specific domains. And if we are entering this world where we're no longer CPU bound, we're no longer looking at Moore's law as the constraint on how fast technology goes, we're looking at how do we build the right pipe to shove data into, and how do we get enough data to shove into that pipe. That's a very different question than can we add more transistors to the same surface area of a chip quickly enough.
Yeah, no, it definitely is. And I think a lot of what you're going to see is there's going to be this mismatch between investment opportunity and the future of AI, because this last wave of software of the cloud has been going on since, I don't know, 2006, 2007. We've become used to a certain way of thinking about how you start a company, what that consists of, but these things are being broken down. And so it's really only going to be your sort of crazier VCs, the ones who are a little more out there, who are going to catch the next wave of companies that are going to be really big, because that wave of companies is going to be bringing some of these different ideas and some of these unique ideas, new ways of doing things, right? But if you think about the things that you hear, starting a company's never been cheaper. No, for AI companies, like, you have to acquire data sets. Sometimes you have to build a product that'll acquire a data set so that you can do something with that data set to build the product you really want to build. Data scientists are expensive. You need, data pipelines and data cleansing. Like, they're much more expensive than, starting particularly these sort of like consumer social companies. I mean, you used to be able to do a lot on $1.5 million. You'd be lucky to get an AI prototype on that.
My friend Oren Hoffman is working on a company called SafeGraph that is doing this data set democratization thing. And initially, when he was started to talk about this publicly, I didn't quite understand, like, why is this data set democratization, data sharing thing important? But as I've heard from people who are deep into the industry, and now I'm hearing it from you as well, this data set, getting access to these data sets it's burdensome. And if we could have mass adoption of data sets and democratization of data sets, a lot of this is rooted in the difficulty of anonymization, I think. If we can have anonymized data sets, that would be great. It's so easy to de-anonymize a lot of data. So, I know it's a lot of interesting problems there. And what you're talking about with the investing, and how you really need these savvy, gambly, perhaps, investors to come in and make these kinds of investments, it's an interesting field to be in. It must be interesting for you as an investor as well.
Yeah, I've done 17 angel investments now in the last year and a half, and I think maybe 12 or 13 of them are related to AI. I've done pieces all up and down the stack. So I did a low-power voice neural network chip, a company called Isocline. I think they're an amazing company. They're going to do awesome. I've done a bunch of different pieces of software. So a company called Reality.ai out of New York, which is sort of like middleware, makes it easy to design and deploy your own, machine learning models for sensors that are tied to physical phenomena that you're trying to detect in sort of IoT devices. And then a bunch of application layer stuff, right? Like end user AI lots for sales and marketing, some for legal and different stuff like that, some machine vision applications. So I've loved it. And part of what, people ask sometimes, how do you have time to do all this? Like, if I like the team and I like the idea, then I'll do the investment. I don't do a whole bunch of diligence, competitive analysis and everything else, because I do it as much, like, I'm hoping for good financial returns, but I'm also betting in a sort of rising tide lifts all boats, theory for AI. And I'm looking to learn more about the industry and see the inside of how some of these companies work and see what I can learn from them and the stuff that they're doing.
Sure. Well, it's also interesting because maybe some of your downside risk that might otherwise be execution risk is not as big of a deal, because a lot of these AI companies just get acqui-hired because there's such a struggle for talent, which might protect some of your downside risk. So I do want to talk more about company strategies and how AI looks at a technical level today, but I want to ask you a little bit more about some far-flung societal questions, because you spend a lot of time thinking about these, and I've looked at some of your thoughts on them. So AI risk is heating up as a topic of conversation. For a while, this was something that part of the community was really saying this is just not something we need to worry about at all. Then obviously people like Elon Musk and Sam Harris have started to sound the alarm. Stephen Hawking, Bill Gates. I think at this point it's fair to say that AI risk can be categorized as something that is sort of like a tail risk from our current point of view, but it's something that we're going to have to tackle eventually. So in some sense, it is an inevitability. And I mean, maybe it's an inevitable tail risk. That's another way you could look at it. Like, eventually we're going to be dealing with a situation where there is some percentage chance of AI turning us all into staples, or whatever Nick Bostrom says.
Yeah.
So
paperclips.
That's what. I knew it was some office supply. So what's your take on this? I mean, AI risk is a thing, but I guess more, to what degree is it a thing from your point of view, and what can we do about it?
Yeah, boy, I struggle a lot with this question because I'm not necessarily convinced that an AI will be nefarious if it happens. And, I don't really have a strong prediction for if that's 10 years away or 25 years away or 50 years away. I do think it'll happen at some point that we'll build machines smarter than ourselves. I buy Sam Harris's argument in general that while we could augment ourselves, we probably don't augment ourselves faster than we create an AI. But one possibility is, something like some technology like a neural lace, right, or some other neural technology takes off, and we're able to keep humans on par with AI, and it's not a big deal. But I think at this stage, it's difficult to assign probabilities to what might happen, and there's probably some things that we don't understand. I know in my own life, I look at my business career, and I look at like one of the biggest business development deals that we ever did in my last company. We had this meeting, and we highlighted okay, we're about to close this deal. Let's go through the list of reasons that it might fail and risks that we might have, right? And we spent, 2 hours, and we drafted 20 of them, and we felt like, okay, we've covered all the things. Sure enough, the deal fell through for a reason that wasn't on the board, which was the company got their CEO replaced. There was a shakeup, a change in strategy. Like, everybody that we knew and worked with had left. There was no more support. Like, it's that stuff happens. And I think it's difficult for us to understand sometimes the unknown unknowns, right, of where these things might go. And so there's so many things that could happen. And I think the way it plays out depends on, does generalized AI, come from the military? Does it start in the United States? Does it start in a robot that has to have some grounding, or is it in a box that's just connected to the internet? I mean, you could make the argument that, hey, before we have generalized AI, we'll have pretty damn good military robots that won't be entirely smart, but will be relatively autonomous. And those things could be programmed by somebody to wipe us all out, before we even get to GAI. So there's a lot, to that. So I don't, I spend time thinking about different ways it might play out, but I don't have a strong opinion for what it might be or what we could do at this point to prepare for it, other than just keep having the discussion, right? I believe the saying that chance favors the prepared mind. So at least if we've thought about it, we'll have some good ideas maybe.
Agreed. And on that matter of chance favoring the prepared mind, we are hurtling towards this highly automated world. Obviously, the AI conversation quickly shifts to the basic income conversation here. You have written about a variation on this universal basic income, universal basic robots, which is basically this idea that instead of just giving people a stipend, you give people perhaps a general robot that maybe can till the land and give them like farmland and stuff like that. It can clean their house. And my response to this was the same response I had to the first time I read Basic Income, which was like, this is preposterous. Why would this ever work? But of course, my opinion has completely shifted on Basic Income. Now I see it as like, this is just something that's very plausible. So explain universal basic robots.
So it came from a discussion that I was having with some various friends of mine, and the real challenge here with universal basic income is I think it's hard to pull off, right? Because what you're seeing as we transition to more automation is you're seeing a change in the shift of income that goes to capital and the shift of income that goes to labor. And you're seeing more and more of the income go to capital instead of to labor. And so universal basic income doesn't fix that underlying structural problem. All it does is say, hey, you capital owners, you're getting too much, we're going to tax you and give it to labor, right? So you're still putting, they're owning capital, owning economic, creation and production power is more than just the cash that it generates, right? You have the ability to strike, you have the ability to say, withdraw your assets from the market and do all these kinds of things. And so I think if that's the approach, hey, all the capital is going to be concentrated in a handful of people who own all the robots and all the AI, and then we're just going to give everybody else a UBI, I think you're still going to struggle with all kinds of problems, right? Because the same people are still going to have, power is going to be hugely concentrated. And so the problem that you really want to solve is you want to say, how do we distribute capital to more people? And there's a couple of ways to do that, right? One would be to say, okay, look, if you're an AI company, you have to put 10% of your stock in a common pool that goes to the government or goes to some, group that then gets paid out. You have to pay out 10% of your income in dividends, and that goes to people, right? Or something, which I know sounds a little bit the same, but it actually starts to change the underlying structure. But as I started running the numbers on some of those things, they create a lot of their own problems as well anyway. And so that's when I just sort of had this thought of, well, look, why not just, if smart robots are going to do everything, why not just give everybody a robot instead? And so the government, rather than paying you, $10,000 or $20,000 a year or whatever it'll be, we just give you a robot one time. And, it seems like it would be more politically palatable, right? It's fair to the left in the sense that, hey, everybody gets the same thing. When you turn 18, you get your robot. And it's fair to the right because what you do with your robot is your choice. If you say, I want my robot to basically grow pot so I can smoke it up all day, like, okay, that's one thing. And if you say, I want my robot to, build these things and then charge other people to use them and then use that money to acquire more robots and do these other things, then you can still amass wealth if that's what you're interested in. And if you want to just, move off the grid and, live in rural Montana and have your robot be your, farmer and hunter and defender of your land, then that works for you as well. I mean, these hopefully will be pretty powerful, intelligent robots, and they won't require much power and whatever. So, I mean, I got a lot of really good responses to that. Some funny, like, oh, great, you want the government to build robots? They're definitely not going to work, and they'll be the worst of the worst, and they'll be overpriced and everything else. But and then I got a lot of criticisms about why it wouldn't work, and I got a lot of sort of affirmations about things people liked about it. So it was one of my more popular, I think, commentaries in terms of the amount of feedback that it solicited. But that's the general idea, right? The problem I'm really trying to solve is how do you more equitably distribute capital rather than income?
Well, the other government things that you've written about, the intersection of government and artificial intelligence, I think you wrote recently about this legislation that went into place in the UK, I think, about how the artificial intelligence companies, trying to legislate against AI stuff is going to be really difficult, especially right. With the technical sophistication level of our current legislators. This is worldwide, our current legislators. But you did point out that the legislation of liability, like if your AI screws up, if your self-driving car crashes into a guardrail, you're liable. The person who wrote the AI, if we can track it, is liable. It's an interesting first step towards AI policy. I really hope that, if in the U.S. we survive this presidency, it does seem like the technical side of our industry has woken up and is saying, okay, we've had enough of these politicians. Let's step in and start to do things politically the way that we do them on the tech side, which is more well-reasoned. And I think it's too early to tell how that, assuming we make it over that 4-year, 8-year cliff and survive, I think it's too early to tell where government is going to go. But one question that I do think is interesting to examine at this point is, what is the public perception of AI? When you think about not just Silicon Valley, Boston, New York, these technically elite cities, does the public have an idea for how fast AI is moving? Because I talked to my parents, for example, or some of my less technical friends, and they seem like they just don't get it at all. They don't understand that this is a really incredible time of how fast the pace is moving. Does AI even enter into the concept of the public perception? Or what's your sense of that?
Yeah, boy, that's a great question, and there's a lot in there. So I don't think your average person thinks very much about AI or realizes where we are. I think they probably even still feel like self-driving cars are a long way off, and they probably think I wouldn't let a car, drive me. And I think that's problematic, right? I think the fact that so many tech jobs have clustered in, maybe 3 major hubs and another 4 or 5 minor hubs around the country is a problem for a few reasons, right? One is that, sort of as you mentioned, there's a small number of people who are sort of seeing and creating the future, and then everybody else has to deal with those. And I think a lot of what you've seen in this election is that there are whole swaths of the country that has a different set of problems that tech is not tackling necessarily. And I think tech is sometimes removed from some of the problems that we create via, automation and, even things like social media, maybe addiction or some of that stuff. And then you have this, tech has typically been in this unregulated, hey, we don't care about government, leave us alone sort of mindset. And as a result, you don't have a lot of strong tech understanding amongst politicians or government. Not a lot of tech people have become politicians. And in fact, we haven't really participated much in the political system. I mean, other than just voting, but like, gone to Washington. I mean, Google and Facebook and some of those companies do some lobbying now, but that's all relatively new, like the last 4 or 5 years. And I would say until the sort of Snowden revelations that really sort of shook the foundations of the tech community, I think tech was almost entirely out of it in terms of what they, thought or cared about policy. And so that's been one problem. And the second problem has just been the fact that, I grew up in Kentucky, right? So I understand the mindset of, someone who lives in a very rural place where
the hillbilly elegy.
Yeah, your nearest neighbor might be a mile and a half away. You might actually hunt some of your food, which I know sounds crazy to my friends here in Boston. But you think about the world very differently when you live down in Cambridge, Massachusetts, and we're like, look, there's no place to park. We're all jammed in here together. It's tight. We've got to find ways to just get along and make the best of this sort of crowdedness and be nice to each other. Versus like, hey, I farm and sometimes I don't see anybody outside of my family for a couple of days, and I'm incredibly self-reliant and like, I don't know what I'd do if I didn't own a gun. And not having those people live next door to each other and have to interact every day, even if you disagree with somebody, like if you have to go to work with them every day, or if they're part of your family members, like you typically disagree, but you're a little nicer about it, right? You become a little more tolerant. And so I think the tech divide and the geographic divide that's been driven by technology, job creation has also enhanced some of the viciousness, on both sides of the aisle. So. And then, to get back to the sort of the start of your question, there's two interesting trends in Europe, right? One is this law that they're debating that says if an AI algorithm makes a decision about you, it has to be able to explain why that decision was made. Oh, you were denied a credit score? You were denied a credit card? Why? Right? Well, some of these models aren't very introspectable, and we can't really explain, we can't say, because this node has a 0.3 weight, right? Well, that doesn't mean anything. So that's going to do one of two things. It's going to drive people to solve the introspection problem of neural networks. And there's some interesting work at MIT and other places being done on that. And it's going to lean people away from some of these AI solutions to other solutions like probabilistic models. Bayesian models are a little easier to understand and introspect. So you might see, it might drive some regulation like that might drive a different type of innovation. And the second point is this sort of other stuff that you were talking about, which again is stuff happening in Europe where they're saying, okay, well, how liable is the creator versus the user? If one company A makes the robot, I buy the robot, I rent the robot to you, and the robot does something bad, how much are we all liable if the robot's autonomous and learns on its own? And so they're sort of saying, well, you're liable to the percent that you had something to do with how the robot got to this state, how much you programmed it or taught it or whatever. And so that's a very interesting, but I think, decent approach for where we are in the life cycle of this stuff.
Simplify continuous delivery with GoCD, the on-premise, open-source, continuous delivery tool by ThoughtWorks. With GoCD, you can easily model complex deployment workflows using pipelines, and you can visualize them end-to-end with its value stream map. You get complete visibility into and control of your company's deployments. At gocd.io/sedaily, you can find out how to bring continuous delivery to your teams. Say goodbye to deployment panic and hello to consistent, predictable deliveries. Visit gocd.io/sedaily to learn more about GoCD. Commercial support and enterprise add-ons, including disaster recovery, are available. Thank you to GoCD and thank you to ThoughtWorks. I'm a huge fan of ThoughtWorks and their products, including GoCD. And we're fans of continuous delivery. So check out gocd.io/sedaily. Let's talk at a more substantive level. It's very fun to talk about the future, but thinking about the present, especially from a business context, might be helpful to people. You are working on Talla, which is an AI intelligent assistant. It works with chat interfaces like Slack and HipChat and Microsoft Teams. Since you're building this chatbot, you think very deeply, I can tell, about the pace at which the chatbot interface is moving. Obviously, the voice interfaces are at top of mind for you as well. But talking, I guess, more generally about all the companies in this space, I know you're right about all these different companies. I see kind of like at least three, for the big companies, I see three trends. I see like there's like Google type companies that are offering the building blocks of AI to developers. There are the hardware companies like Intel that are making specific chips for machine learning, like we discussed, and perhaps you will have a cloud offering where you can run your deep learning jobs against Intel's cloud with their specific chips. Then there are companies like Salesforce that are building AI into their products. And then there's all of the smaller companies. We've seen lots of innovation in AI from smaller companies. Many of these companies are getting acqui-hired. How should a developer look at this space, whether they're a developer at a smaller company or a bigger company? And perhaps, in your work at Talla, how does the work of a software engineer change in this space, and how does it depend on the size of the company, the type of company that they're working at?
Yeah, a lot of great questions there. We think a lot at Talla. We think we have to build full stack. And the reason that we are building most of things in-house, well, there's two reasons. Number one, if you're building for the enterprise, you ultimately want to be able to offer an SLA. So we've looked at tools like API.ai, which is, a great tool, but they're a startup too. And if we want to offer an SLA someday and they can't offer us one, then that makes it difficult for us to, give 4 nines to our customers of uptime or whatever they need. So you don't want to be relying on a third party. And that applies for other types of technologies. We looked at a company called Message.io, which is another great company that'll help port your bots to lots of platforms. Again, we felt like we wanted to own those connections as well. But I also think for enterprise use cases where data security matters and, you're not using public data sets, you're using stuff that the company has, I think there's going to be a lot of chances to tweak your solution and to really get some gains by controlling more pieces of the stack yourself. You can do some optimizations across the type of data that your customers have, which when you're building a horizontal platform, you have to be very generic, right? You have to support a lot of different use cases. So, you take something like Amazon DynamoDB. It's probably fine for most types of scalable sort of NoSQL database use cases you need. But for some subset of use cases that's probably still pretty high, like 20 to 30%, you're probably like, what? It would be better to use, run our own clusters of, Mongo or Cassandra or whatever you want to do and tune them to our own needs. We'd probably get better performance and at scale, maybe a cheaper price. It's more capital to get started and everything else. And so again, when I talk about some of these companies aren't as cheap as they used to be, and that's part of the reason. So we have a lot of these discussions about what to build and what not to build. And I think if you're building, particularly for enterprise AI right now, I think you probably want to build more of the stack yourself. Probably in 3 years, that's not the case. But that's sort of where I think it is today. And so I think if you're an engineer, I think you're just looking at, I think it depends on the kind of company that you want to go work for and, how deep in the machine learning stack you want to be with respect to the tools you should learn.
Okay, so this is really fascinating because the build versus buy question, before I started doing a lot of shows about AI, when most of the earlier shows I did were sort of, you're building a web app, you're like an Airbnb company or you are Slack or something. Well, I guess maybe Slack is arguably an AI company, but these companies that are just like a web app, basically, the argument would always be you should always buy. Don't build, buy where you can because it's going to save you time. But I think what I'm hearing from you is that in AI, perhaps you want to build because performance is so paramount. Just the other question, and you can choose whether to discuss this or not, but I mean, Google's hosted machine learning, for example, like they take care of something that's very unique, which is like the scalability aspects of running your machine learning jobs. I've heard very good things about the Google Cloud machine learning framework. Perhaps that's only useful for very specific domains. But yeah, I guess explore the build versus buy question when it comes to AI companies.
Yeah, so if I was building most sort of general web apps today, I would agree with you, right? I would buy almost everything. And the only thing you want to build is the small specific piece that's relevant to you. Today in AI, there's a couple of reasons that you want to build. And one of them is just a maturity issue, right? It's back to the SLA stuff that I mentioned before, which is the ecosystem's immature, so you can't really rely on the other pieces of ecosystem to be as good as you need at this point. And you don't want to get in a situation where you pick a platform and you're one of only, 30 or 40 early stage customers they have, you don't know how their product roadmap is going to develop and if it'll stay useful to you, right? Compared to when they have 10,000 customers and they're hearing similar signals from everybody and they're announcing their product roadmaps a little bit in advance and all that. So you introduce a lot of risk, right, by doing that. Plus, you don't know yet which of these startups are going to be standalone and who's going to buy who. And so you have this risk that, if Google buys somebody, do they shut them down? Do they change their roadmap? Do they,
the parse risk.
Yeah, there's all kinds. Yeah, exactly. Yeah, the parse risk. So you have a bunch of risks like that. But you also have this risk where I think sometimes, like, I'll give you an example. If you're working on NLP, I'm not sure that you know yet what the most valuable piece of your stack is, right? And which pieces are going to be, easily available via open source and everything else. I mean, you can make some guesses like, syntax parsing is not going to be where you're going to make your stand because that's a pretty well solved problem. So I think it's something that you got to spend a lot of time thinking about. And I think at this point, it still makes sense to build a lot because the battle scars that you get and the things that you learn, if nothing else, if you decide to go buy at some point in the future, you've really learned a lot about what product you need. And it's different because like if you need to go choose a NoSQL database, there's a lot of people that understand those, that used them in the early days and can tell you, help you make a decision, and all that's relatively well understood. And a lot of the AI stuff is not. And so I think you want the opportunity to be able to tweak things for your own needs, to be able to, if there's some brand new idea that's coming out of academia or something, like try that out. I mean, and we tried, when we started Talla, for the chat piece, we tried IBM Watson, we tried wit.ai, we tried API.ai, and they were all fine tools, and depending on what you're doing, they may work, but none of them really worked for our use case. And so we ended up rolling, they were just too early. So we ended up rolling a lot of our own NLP. And a lot of what you want to do, honestly, just frankly, in the AI world and the NLP world at this point is you don't need to solve every problem. Like sometimes you just need to put, UX and UI rails around some of the use cases and drop little hints for people about how they should speak and talk and communicate with your bot so that, you don't have to handle every use case at this point. And so you have a better ability to do that if you control your own product stack.
It's funny because chatbot investments really heated up about a year and a half ago, where people were just like, chat bots are everything. And then much like investor trends do, it like petered out. They say, okay, chat bots, it's not fashionable anymore. It was just funny because like throughout the whole time I was like, it's just an interface. Like it's an interface to advanced AI, and the AI is fundamentally getting better. It reminds me of Bitcoin, where like there's the fashion of Bitcoin for a while, and then investors said, okay, Bitcoin's not fashionable anymore. It's like, what are you saying? Like, Bitcoin is it's still a fundamental advancement in computer science. Why would you start to say, no, it's not fashionable anymore?
Right.
There's no killer app for Bitcoin. It's a fundamental breakthrough. We've had fundamental breakthroughs in AI. Chatbots are a mere interface into that AI. So I guess where are we in and I think part of it is like, when do we get the bridge between the conversational Amazon Echo type of interface, the voice interface, and the chatbots that are effectively the same thing? I mean, does it take an AR product to get us to where voice becomes, more prominent in our world? I mean, we're still in such early days of voice. I guess what is it going to take for people to realize that these things like voice and chatbots are not fashionable? These are a completely new platform that is just really going to be a paradigm shift as big as mobile.
Yeah, I think there's three things that have held these things back, right? And so I believe voice is going to be big, but I believe it will not be big at work, right? Because since most people have open office floor plans, you can imagine having 20 people in a room yelling at their devices, trying to, talk over one another. I don't know if you've heard people try to, argue with an Alexa at the same time. Like, it confuses Alexa, right? And somebody says, hey, Alexa, play. And then somebody else jumps in and goes, Alexa, play, this other song. And they try to say it faster, and Alexa gets confused. And so I think it would be really weird for us to sit and talk to our devices right now in open office spaces. Now, the way this will evolve is, I think, one of two ways. Either as voice becomes more prevalent and we get used to talking to devices in private, we'll get more comfortable talking to them in public without feeling weird. Or you may see a return to, more closed off private office spaces. I mean, there's a lot of arguments for that. And then you might see voice rise in the workplace again. So that's one point. In terms of chatbots specifically, I think they're primarily going to be text driven through Slack, HipChat, Microsoft Teams. maybe Cisco Spark and some others that are coming up. But I think there's two things holding them back, right? One is it turns out a lot of things are really hard to do just through conversation. So if you look at Talla, right, and some of the things Talla can do, help schedule recruiting interviews, help with employee onboarding, help answer basic HR questions. What we found was while having a chatbot interface is nice and is a better experience than email, trying to do your configuration work and your setup work and all that through a chat interface by explaining to the bot what you need is miserable. And you can think about this in human relations. I mean, you and I could be having a discussion and I might say, actually, here, Jeff, let me draw it for you, right? And jump up to the whiteboard. And that happens a lot. And so I think what you've seen with all the popular bots that have been out for a while that are focused on enterprise, they're all going to a web interface plus a bot, right? So this is what I think you're going to see. I think the trend is that every enterprise application category is going to be rewritten to be intelligent and conversational. The web piece is not going away. It's just going to be built in a way that makes it highly conversational so that you can do a lot of it through a bot interface. And then the second thing that we're waiting on is, the NLP is going to get better as we get more chat data sets. I would love to see Slack take their data sets, scrub them of, certain sentences that contain proper nouns, scrub them of identifiable information, and release them so that bot developers could use them to train models, or for Slack to provide your general, some level of NLP, model at some point. But I think these things are going to happen and are going to drive things forward. And I think the next couple of years are going to be really big for that.
Okay. Well, Rob, it's been really interesting talking to you. I'm a fan of your newsletter. I also saw you talk at the Launch Scale Festival, I think. You gave a very interesting presentation. Is that on YouTube?
It's a good question. I don't know.
Okay. Well, I don't know.
Yeah, we'll have to figure that out. Jason's a good friend of mine, so he's invited me to speak at those things a couple times. So they're a lot of fun.
Yeah, great stuff. Okay, cool. Well, thanks for coming on Software Engineering Daily, and I'll link to Technically Sentient and Talla and everything else in the show notes.
All right, thanks for having me, Jeff. It was fun.
Okay, great. Listeners have asked how they can support Software Engineering Daily. Please write us a review on iTunes or share your favorite episodes on Twitter and Facebook. Follow us on Twitter at software_daily or on our Facebook group called Software Engineering Daily. Please join our Slack channel and subscribe to our newsletter at softwareengineeringdaily.com. And you can always email me, jeff@softwareengineeringdaily.com, if you're a listener and you want to give your feedback or your ideas for shows or your criticism. I'd love to hear from you. And of course, if you're interested in sponsoring Software Engineering Daily, please reach out. You can email me, jeff@softwareengineeringdaily.com. And thanks again for listening to this show.